Welcome. Today, we're going to learn how to find the x and the y intercepts of a linear equation that's written in standard form. Now, let's make sure we understand what an x and y intercept are. So, if I was to graph a linear equation on a coordinate system, we always have the x-axis that is horizontal, and we have the y-axis that is vertical. And our linear equation, if it's a line, it could be have a negative slope or something and come down like this. It could be going up or whatever. But when we're asked for the x and y intercepts, we're asking for where that line crosses the y-axis and where it crosses the x-axis. Now, we've dealt a lot with the y-intercept, but we haven't talked a lot about the x-intercept. But yeah, the x-intercept can be just as important as the y-intercept and can help us graph, because if we knew both the x and the y-intercept, it'd be very easy to graph. Now, the thing I want to emphasize, though, is when we're looking for the y-intercept, when we're looking for the point that crosses this vertical y-axis, the x value for that point will always be 0. The y value, I'm not sure what that would be. It could be up, up 2, it could be up 3, 4, 5, 6, it could be down so far. So the y value would be different, but the x value for when I cross that y-axis or wanting the y-intercept, the x value is always 0. If I want the x-intercept, so I'm crossing somewhere along here, this x-axis, the y value will always be 0. I'm not sure what the x will be, but whatever this point is, I'm not vertically up or down at all, so it has a y value of 0. So, the trick to finding the x and y intercepts, given an equation in standard form, and what I mean by standard form is you might have something as simple as 3x plus 4y equals 12. It's not slope-intercept form. Directly, we cannot see the y-intercept, and we don't know the x-intercept. But to find the x and y-intercepts, if you're asked to find them, what you do is this. If I want the y-intercept, I'm going to make the other variable 0. So I think, okay, if I make this x value 0, that's going to be 3 times 0 plus 4y equals 12. Well, what's 3 times 0? Well, that's just 0 plus 4y equals 12. Do I really need the 0 here? No, it's 4y equals 12. That's a one-step equation that I can easily solve for my y value. Divide both sides by 4, and I get a y value of 3. So my y-intercept for this equation is 3. And I got that by making x 0, 3 times 0, 0. That term goes away, and I'm left with just this part of the equation, that 4y equals 12. I divide by 4 and get my y value. Now, if I wanted my x value for that same equation, so now let's say, and I'm going to rewrite that equation so we don't, that exact same equation. Now, if I want my x-intercept, what you're going to do is you're going to make the y value 0. The other variable is 0. So if you're looking for x, you're going to make the other variable, or y, 0. So again, that would be a 3 times x, because now we're looking for some unknown x value, plus 4 times 0 equals 12. Well, what's 4 times 0? Well, that's just 0. So it's 3x plus 0 equals 12. Do I really need to write the 0? No. It's just 3x equals 12. So again, I get to this one-step equation that's very simple to solve. Divide by 3, and I get x is 4. So when I plugged in a 0 for y, I get an output, well, not an output, my x value is really my input, but an x value of 4. Now again, just like the one when I was looking for the y-intercept, if I plug a 0 in for this y, this term in a sense becomes 0 and goes away, and I'm left with just the 3x equaling, so I'm trying to cover up that 4y, and just it leaves the 3x equals 12. Well, you can solve 3x equals 12. So if you're looking for the x-intercept, just take the x term with the other side, 12, and divide the 3 over. Now, in solving these standard equations, a lot of times our solutions won't be nice solutions. They can be fractions, but that is perfectly fine. So if you're given something like 5x plus 7y equals 13, and I want to know the x-intercept, well, the x-intercept has a y value of 0. So again, if I make this y value 0, this goes away, leaves me just the 5x equals 13 to find my x-intercept. So I have my x variable in there, divide by 5, and I get my x-intercept is 13 fifths. Nothing wrong with 13 fifths. It's 13 fifths. If I want my, and by the way, again, that was my x-intercept. My x-intercept, slide that over a little bit, there we go. If I want my y-intercept, I make my x 0. Again, plug a 0 here, 5 times 0 is 0, that term goes away. We're just left with the 7y equals 13. Divide both sides by 7, and we find out my y-intercept is 13 sevenths. So again, in standard form, if you want your x-intercept, you make y 0, which makes that term go away. You're left with a one-step equation. 5x equals 13. Divide the 5 over and you find your x-intercept. If you want your y-intercept, you make the x value 0, which makes that term go away. You divide the 7 over and you get 13 sevenths, or your y-intercept. If you have any questions or you're still confused, please be brave enough to ask me for help in class.